Okay, now we're gonna measure our device. It's already connected to the cable, and that cable is connected through the junction box over here. So now the way you set the proper measurement ranges is by clicking the AD settings, which is um, analog to digital settings. So you click here and this window pops up, and there are different measurements you can do. If you want to have a measurement of the frequency behavior of a signal, you can use FFT. If you want to just measure how it behaves under a sinusoidal wave, you can click on fast scan, and that enables or disables different tabs at the top over here. In our case, we are interested in detecting the resonant frequency of our device, so I'll use an FFT. Depending on the type of measurement you're doing, you might want to have averaging of your signal. So averaging of your signal will decrease the background noise, but it'll take longer time. If you are measuring in the kilohertz range, that's going to be affected. The time it'll take to measure will be greatly affected by that. But if you're working in the megahertz, it's not that problematic. So I normally do complex, and I start with 10. There are different type of averaging, magnitude, complex, peak hold, but complex is a good one. It's like a good reference. Now we're going to the second tab, which is channels.
So it scans it 10 separate times and averages the result.
Mm-hmm. So the next tab is channel. There are two different rows here: vibrometer and reference. So the reason we have that is that in reality we have two laser beams, and this system can be used in how's it called, in the differential mode. So you can have a moving structure within another moving structure and still capture the movement. The reference signal is connected to a mirror, which is behind that scanning head.
So it's not connected now.
It's not connected, and it is not connected. Well, it's connected to a mirror, so that'll give you like a way better measurement rather than if you set it directly in your sample. So that equipment will work for 99% of the cases. If you were
without the reference, yeah.
Yeah, without the reference. So that's why you want to modify only this one. The vibrometer, the range, you start with a small range, and increase the range if it gets saturated. You'll know what I mean. And the type of the measurement, since we are going to use in the megahertz range, click displacement decoder, because that's the same decoder we have connected in the junction box. Okay. So now displacement decoder and low voltage range, that's your starting point. Next tab. So filters.
For low
Not
frequency
recommend.
one, I would recommend using the band filter, band pass filter.
Yeah. So that's yes, that's Chang is correct. So if you are measuring something in the lower range, and if you are getting some mechanical noise from the background, a band pass filter will work. And for the frequency, let's go to vibrometer first. So remember the different decoders I show you, like the displacement decoders and the velocity decoders, they are here. So this tab controls the different kind of decoder you want to use. And for instance, if you want to measure a low frequency signal up to 20 kilohertz, you select this one. VD06, and we have VD02. Okay, so we only have two decoders, but with multiple subdivisions on each one. And the main difference here is the frequency range you can detect with each one. So for instance, the VDD01, 1 millimeter per second per volt, gives you up to 20 kilohertz. If you select the next one, it goes to up to 100 kilohertz. If you select the third one, it goes to 350, and so on and so forth. So rule of thumb, select the decoder that gives you that falls within the range of your measurement. If you want to measure something that vibrates at 80 kilohertz, then select the decoder that has a maximum frequency of 100 kilohertz. So this way you'll have full resolution, like almost full resolution of your decoder. Okay, so you'll have the highest bandwidth. Because otherwise, if you use a higher decoder, you can still get measurements, but you'll be wasting a lot of bandwidth of the decoder. That's why. Okay. In our case, we are using a displacement decoder, so even if I select any one of these, they won't be enabled because I'm on measurement displacement. And the displacement here, it has two displacement decoders, but the one we are interested in is this DD300, and it's in the auxiliary port. That's why it's between parentheses. And okay, so we have another displacement decoder, and that's probably the one connected in here. Okay. For our case, we're going to use the auxiliary one that goes up to 20 megahertz. That's the only option we have for this displacement. Okay.